Hello guys, welcome back to Maison African Motives, still on the question paper, which we have written in June 2022. A continuation now on question number 5, so we are not going to waste much time, going to quickly rush through the questions that were given so that we are able to understand how to attempt these typical questions. So on 5.1, we are given to find the integral of e to the exponent of minus st f of t dt if f of t is equivalent. Take note, we are given that in place of f of t, we are supposed to use 0.5t. So in place of f of t here, we are going to substitute 0.5t. All right, so what does this statement going to look like at the end? I'm just going to write it here so that it can be easier for us. So this is 5.1. All right, okay, sorry for that, guys. I thought I have indicated here. All right, so this is the integral of e to the exponent of minus st. That's 5.1. The integral of e to the exponent of minus st by f of t. And we are given that our f of t is 0.5t. So you're going to multiply by 0.25t with respect to t. All right, from 0 to infinity. All right, so that was the question that we are given to integrate. So what are we supposed to do for this particular question? As we can see, it's the product of the two, and 0.25 is just a normal number, just like 1/4 from calculator. This is 1/4. So we can just write 1/4 outside of the integral. So this is 1/4, the integral of e to the exponent of minus st by t, of which you can write as t by, because we have removed this 0.25 outside of the integral. So that would be t by e to the exponent of minus st. So s is just a constant, just like 5, just like 7, just like any other number. So definitely these two terms are multiplying each other. So the best thing that we can apply is definitely by parts. So we are supposed to think of applying by parts method, where we understand that by parts method is states that the integral of f of x g prime x dx is equivalent to f of x by gx minus the integral of f prime gx dx. So this is what we have. So from this part, there is a need for us to actually have our f of x and our gx. Our g prime x. So which one is going to be your f of x depends the part that you can integrate, or that you can find its derivative, which is easier, and that can be a t there. Yes, you can choose e, but it's easier that way if we choose to be t. So let's say here we are just going to have it as we can see. Let me write the way that we can understand, because this is f of x, so we can actually have it as f of t here, g prime t dt, the way that it is equivalent to f of t by gt minus the first derivative with respect to t, gt dt, since this expression is in terms of t, so that you don't confuse yourselves here. All right, so our f of t is going to be represented just like f of x. This will be our f of t, which is t. So we need the first derivative with respect to t, which is a 1. All right. Then the rest will be g prime, which is we are going to be left with e to the exponent of negative whatever that we have there. So this is our g prime t with respect to t, which is equivalent to e to the exponent of minus st dt. And as we know that from this, we are supposed to integrate both sides so that we can have gt. So gt is equivalent to the integral of e. Remember, for you to integrate e, we are supposed to divide by the derivative of st here. So it's going to be e to the exponent of minus st. Then you divide by the derivative of f of t here, which is minus s. So you're going to divide by negative s. All right, so this is what you're going to have from this derivative, or from this integral. So you can even write the negative on top, which is negative e to the exponent of minus st over s. All right, so with this, we are going to substitute because we are supposed to integrate this here. So let's substitute into the integral now of f of t, so that we'll be able to integrate our integral here. So we're going to substitute f of t by gt on that expression. All right, so I'm going to take this aside. Let's just hope we are going to win here. All right, so let's take this. Okay, it's now far away. Or I can just use this side. I can just use this side here. All right, so this is going to be the integral of we had 1/4 before there, so we are going to just have 1/4 on our answer. So whatever that you're going to get, multiply by 1/4. So this was the integral of 1/4, the integral of this to infinity t by e to the exponent of minus st dt, which is going to be 1/4 outside of the integral. All right, so this is what you're going to have inside. We said f of t by gt, where we have our f of t, which is t, and our, okay, let's write stage by stage, our f of t, which is t by gt, which is negative e to the exponent of minus st over s, minus the integral of f prime t, which is 1. So this is just 1, so it's not going to affect anything, by gt to the exponent dt. So our gt here is negative e to the exponent of minus st over s with respect to t. All right, so we have taken that part into consideration. That means we can be able to proceed from this case. All right, not forgetting our limits from 0 to infinity. So here we still have the integral that is supposed to take place here, but we took the integral of e to the exponent of minus s. It gave us the same thing as minus e to the exponent of minus st over s. So definitely these two will multiply each other with the s, because we have got an s which is there in the denominator, so it's supposed to be over s, and this will affect each other to be s squared. All right, so that means we are going to have our answer as 1/4 into minus t times minus this. You can write it as minus t e to the exponent of minus st everything over s. All right, minus, here we are going to rewrite this as it's now s squared. So it's positive because there's a negative here, so it's now positive. Okay, previously it is supposed to give us a positive. Okay, then when we integrate, our answer is going to be a negative. So positive and negative, so it will be a positive, it will be a negative at the end. So this will be negative e to the exponent of minus st over s squared. So we are going to have s squared there. All right, everything to the limits that we are given there. All right, then on the application now of the limits that we have, we are going to have 1/4 into, we can try by all means to separate, because here we are supposed to substitute the limits where there is t. All right, where there is t. So if we are to substitute where there is t here, we are supposed to substitute the infinity here, the infinity here, the infinity here in place of t, of which if it is to the exponent, or e to the exponent of infinity, it actually approximates to a 0. So that means here we are going to have a 0. If we substitute the infinity, it's going to be a 0 minus a 0 there. All right, so that is for infinity. Okay, minus the lower limit when it is a 0. When t is equal to 0, here we have a t which is multiplying, so definitely this is going to give us a 0 here. Then here we are going to have e to the exponent of 1, of which e to the exponent of 0, sorry, this one gives us a 1. It actually is equal to 1. So we are going to have 1. So that means we are going to have 0 minus 1 over s squared. Take note, the limits, they are being substituted in place of t, not in place of s. Okay, this was a derivative with respect to t, so you substitute where there is t. So this will be 1/4 from 0 minus 0, which is a 0 here, minus 0 minus 1 over s squared, which is minus 1 over s squared. So minus and minus, that's a plus. So it is going to be 1 over s squared. So you can multiply by 4, which is 1 times 1, that's 1 over 4 times s squared, which is 4s squared. All right, so that's what you're going to have at the end. This will be 1 over 4s squared. And as you can see, there's nothing that we can do further from there. So that was the integral of the given expression. So it was just a matter of applying by parts properly. That was the concept here, knowing your by parts formula and substituting the values that you're given there. All right, let's check the other part, which is on 5.2, where we are given to calculate the coordinates of the point of intersection from the given two curves. We know that whenever we're dealing with the point of intersection, we are taking where the two curves are the same or they are equal. So actually we can divide by 2 each and every equation so that we can equate these two equations here, so that we can write in terms of y is equal to. All right, so what I'm trying to say is that the first equation, okay, is given as, so this is 5.21. We are given this as 2y is equivalent to 3 minus 2x minus x squared. So you can just divide by 2 both sides, which means y is equal to 3 over 2. Okay, let me just put it this way. 3 minus 2x minus x squared over 2. So you divide each and every term by 2. The same thing, y is equal to, on the other side, is going to be x plus 3 over 2. So this is the expression for y, this is the expression for y. And we know that at the point of intersection, the two graphs, they are equal. So you just have to equate the values or this part of x of the equation. So that is the one that you're going to have. We are going to equate this part since y and y are equal. But by equating these two, I want you to see something here. We're going to have 3 minus 2x minus x squared over 2, which is equivalent to x plus 3 over 2. Since the 2 and the 2 are the same here, definitely they will cancel. Even if you cross multiply, then divide, these 2 will cancel. So you're just going to remain with 3 minus 2x minus x squared, which is equal to x plus 3. So it's a normal equation that you're going to solve. You can transpose your terms to one side of the equation. The x is going to be minus x. So this will be 3 minus 3. 3 to that side will be 3 minus 3, which is a 0. All right. Then x to that side is minus. So it's minus 2 minus x, which is minus 3x. We are left with minus x squared, which is equal to 0. So as you can see, it's a matter of solving for x. So you can factor out x, which is common. You are left with negative 3. Negative x is equal to 0. So it's either one of these brackets must be equal to 0. So definitely x is going to be 0 or x is going to be equal to negative 3. By transposing x to that side, it becomes a positive. So it will be negative 3. So these are the values of x, x being equal to 0 or equal to 3. So to find the corresponding value of y, you're going to substitute into any one of these equations. You can substitute into this or the other one. So let's start when x is equal to 0 and see what you're going to have. If x is equal to 0 here, that's 0 plus 3, which is 3 over 2. And the other point is when x is equal to minus 3. So if we are to substitute minus 3 here, that's minus 3 plus 3 over 2, that's 0. So it's going to be 3, 0 there. So this one will be 3, 0. Okay, so that's the point of intersection for the given two graphs that we had. So you can even write, there are so many ways that we could have done this question, or that we could have worked out this question. All right, let's check the other part on 5.22 is to make a neat sketch to show the enclosed area, the representative strip, and the point of intersection. So you're supposed to show where these two graphs are intersecting, and the representative strip that you're going to use definitely when you're calculating the area, because at the end you are supposed to have or to calculate the area, which is on 5.23 there. We are asked to calculate the area. All right, so how is the representative strip going to look like? That is the question here. All right. What are you going to do? This is a quadratic function that we have. Take note the quadratic, and the coefficient of x squared here is a negative. So which means we are going to have something like this. All right, that's a negative. So what you need is to find the point of intersection. We have them. So we need to find the roots where this graph is going to cut the x-axis by solving for x and y. All right, so by doing that, guys, if you are to solve properly, this is what you're going to have at the end. All right, so this is 5.22. This is a sketch, so you're supposed to know your sketch, guys, from your mathematics N4, N4, N3 there, we dealt with sketches. So this one was going to cut at -3, and it was also going to cut at +1, something like that. All right, having our graph also cutting here at 1,5 for the y-intercept. So we've got something like this for the quadratic graph. All right, so let's just say this point here. And remember the point of intersection for the straight line, that straight line is going to cut at -3 and also at this point here, which is 1,5. So this point, this is 1,5. This is 0.1, this is 3. All right, this is 0.3. Okay, so that is where we are going to have our representative strip. So guys, on sketching this part, I'm not going to waste much time from your revision of N3. I think it can help you to sketch these graphs. So we have our straight line here. We have the quadratic, and the quadratic is the one that is on top. So this is our y2, or you can just name it as y2, and this is y1, whatever that you have. That's the sketch that you're given. And also don't forget the equations that you have. All right, so the part that we have now is the one that we are going to use to calculate the magnitude of the area in question 5.22. So for us to have the area, as we can see, we've got two graphs which are affecting each other, and the area is going to be we are going to find the difference between the two graphs. So it's going to be the one on top minus the one below. So that's the one that you're going to use now when calculating your area, the one on top minus the one below. So I'm gonna write here, this is the one that is on top. All right, so this is the one that is on top. And this is the one that is below or on the bottom. So from there, we need the difference between the two. Okay, remember your area, guys. The area, this is actually 5.23. So our area with respect to x is going to be the integral of the limits a to b, and we need to subtract the 2. So y2 is the one on top, y1 below. So it's going to be y2 minus y1 dx. So it depends. If this is y1 on top, then it's going to be y1 minus y2. It depends the way that you have written it. And our y2 is this function that we have written here as 3 minus 2x over minus x squared over 2. So if you have to divide, you can divide each and every term there by 2. So if you have to divide by 2, you're going to see this will be 3 over 2 minus 2 and 2 cancel, we've got x, and we are going to remain with minus x squared over 2. So that is what you're going to have, or minus half x squared. The same thing here is going to be x over 2 plus 3 over 2. That will be the value for y. So you can just take it that way. So that's what you're going to have, or you just use the way that it is direct. So which means here we are going to have our area with respect to x as the integral of the limits now are taken from -3 up to 0, because we need up to the point of intersection at 0 there. So it's -3 to 0. And let's put in our y2, which is that function of x. So we saw that it was 3 over 2 minus x squared over 2. This is minus that of y1, which is the straight line. And for the straight line, we had x over 2 plus 3 over x. So it's going to be x over 2 plus 3 over x. So that is what you're going to subtract here, x over 2 plus 3 over 2. All right. So by subtracting this, we will end up integrating this, everything with respect to x, that can actually give us the area. All right, so let's start by simplifying first before integrating. So it means we have to expand the brackets by negative here. This will be negative x over 2, negative 3 over 2. So you can collect like terms. That will be 3 over 2 minus 3 over 2, as you can see, to cancel. So you're left with negative 1x negative 1 over 2x. So that will be negative 3 over 2. So you're going to obtain something like negative 3 over 2x. All right, x squared is not going to be affected, so it's just going to remain as minus x squared over 2. So this is what you're going to integrate with respect to x. So let's do the integral, guys, and see what you're going to have. Remember, on your integral, this is 1, so you're going to add 1, which is 2. So you're going to have x squared over 2. But this 2 is going to be affected again by the 2 that we already have. So it's 2 times 2, which is a 4. So it's going to be negative 3 over 4x squared. Minus the same thing here, going to add 1, which is 3, divide by 3. So it's going to be x to the exponent of 3 over 3 times 2, which is 6, with the limits from 0 to negative 3. So we can actually substitute the given limits so that we can have the value of the area, which is the numerical value. So substituting, gonna have minus 3 over 4. That's a 0 here, guys. Okay, let's not waste much time. Here, if we substitute a 0, this will be a 0, this will be a 0 there. So we are going to have 0 minus 0 minus the lower limit. We have got x, which is a negative 3. So you're going to substitute negative 3. So it will be negative 3 over 4 by negative 3 squared. Minus, we substitute negative 3. So this will be negative 3 to the exponent of 3 over 6. All right, so this is what you're going to do on your calculator. Simplify everything properly, then definitely you can obtain the numerical value of the area, which is 9 over 4. So that will be 9 over 4 square units. So these are the typical approach that you're supposed to have whenever you are dealing with area given two functions. Sorry for that, guys. Sorry for that. This thing is now not responding. I don't know what's happening. I think it's the network or something else. I don't know.